All right, good morning, Algebra 1 class here at Animal Watts. Ready to get down and gritty with us today? We're going to be working hard on math and we're going to be able to channel our inner Rocky. So, me and Mr. Roan right here, my name is Mr. Verona. We're going to introduce you to some of our favorite families. And I know Watts family is one of them, but we're actually going to be talking about the function families today. So, we're going to teach you how to be able to function with the function family today.
So what is a function? A function is a relationship or expression involving one or two variables. It has to pass a vertical line test, which is a vertical line drawn straight through the line, and would only cross or intersect at one point.
Alright, so first we're going to start off with the linear functions. These are the type of functions that make a straight line that goes on forever in both ways, and it uses two real numbers. And my partner here, Justin Roan, he's going to be able to draw in the formulas. So we have y equals mx plus b, and f of x, which is another name for a function, we're going to be able to write that in equals mx plus b format as well. So here we have two examples of what a vertical line, linear function can look like. And it does pass the vertical line test because it does not intersect at any 2 points. So just remember, y is the same thing as f of x. And now we'll go on to exponential functions.
So exponential functions use real numbers and they create a single line where both numbers are bigger than 0. They cannot be equal to one, or they will become linear functions. And they are used to show something growing or something shrinking. Mr. Verona is writing down the formulas. You guys can copy down in your notes. And the graphs will look something like this.
Alright, so this is an exponential growth, and then this is an exponential decrease. So you'll see it starts off at a low point and it'll rise all the way up, and this one starts off at a higher point and it'll rise down. So we'll go ahead and get into the quadratic functions, which is one of my favorites. So a quadratic function is a, b, and a c, and it uses all real numbers, and it cannot be equal to 0. Any of the numbers cannot be equal to 0. And they do have an absolute maximum and an absolute minimum value. And you'll be able to tell what a quadratic function looks like because it'll look like the shape of a U. And here's the formula. So we have fx, which is function, equals ax squared plus bx plus c. Or in other words, y, the same thing as a function, f of x. Y is equal to ax squared plus bx plus c. And here we're going to see two examples of parabolas. So let's go ahead and do our vertical line test. Alright, it passes there, passes there, passes there. So that's how you would be able to tell if it's a proper function. And like I mentioned earlier, it does have a maximum value. So this is the minimum value of this quadratic formula, and this would be the maximum value of this one. So you'll be able to see the differences between the two, and they are both quadratic functions. And now we'll just jump into the next function, which is a linear absolute value function.
So a linear absolute value function is a combination of linear functions and quadratic functions. And they look like a V shape. They are quadratic functions because they have they're like quadratic functions because they both have a absolute minimum or maximum, and they're made of two straight lines that connect. Mr. Verona is writing the formulas for the linear absolute value. These ones.
Oh.
And the graphs will look something like this.
Alright, so we have f(x) equals a plus c. Same thing with y.
So we have an absolute minimum, we have an absolute maximum, and you can see that both functions pass the linear vertical line test.
So this is like a combination of the quadratic function and a linear function because it does have the similar shape except for it has straight lines instead. And take a look at the formula. Alright, so the last function we're going to go over with you guys, it's called the linear piecewise function. And this one has different parts, and it'll usually have a break inside of the function. So it'll have maybe a slight change of direction that's abrupt and frequent. So it could also have a break in the actual line, as Mr. Rohn right here points out. And example of the formula would be f of x equals ax plus b, but only if c is less than 4. If it's greater than 4, then we're going to use the x squared instead. And so you'll be able to see that it'll have a break in the function. And so those are the 5 families we wanted to go over with you guys. If you guys have any questions, come see us in our office hours and we'll be able to help you.